All right, let's take a look at this example. 3 equations, 3 unknowns, and let's use Cramer's rule. So first we got to make sure that we write the correct determinant D. Now do pay close attention to the fact that we have some zeros here that are going to show up, right? We can't leave those blank. We do have to give them representation. So we have 1, -7, 0, 3, -4, -2, 0, 6, 5. All right, so there's the first one. Now, like we did before, we're just going to do a lot of copying here. So I'm going to copy this guy, and we're going to paste it down here. We're going to make this one for x, and when we did that, we destroy that first column, and we replace that with those coefficients of -29, -13, and 9. All right, let's paste again, and we're going to write the one for y, which means we have to erase the ones here in the middle. And we're going to write those constants. And then finally, we're going to do the one for z. Erase everything in the z column, and we replace that with those constants. So now we have 4 matrices, or 4 determinants to find. So let's do it. Starting with this first one. Now, we saw before we just kept copying things over and we did the shortcuts. So 1, 3, 0, -7, -4, and 6. All right, so let's see. We got here, here, and here. Now you'll notice we end up with a -20, but since you have a 0 in that column, or in that diagonal, and another 0 there, it's just -20. You can say +0 +0, but it doesn't change anything. Then we have this diagonal, this one, and this one. So that's going to be 0, -12, and -105. So when I put all of this together, so it's going to be -20 plus, oh wait, getting ahead of myself. This is equal to -117. Almost forgot about that. So putting these together, that's -20 and then -117, or minus -117, so plus 117. So our big D is going to be 97. Let's find all the other ones, right? All right. So let me just copy this. So -29, -13, 9, -7, -4, and 6. All right, just to kind of speed the process along, I know we can do all this by hand. Let's use our calculator though. So we've got 29 times 4 times 5, so that's 580, positive 580. 7 times 2 times 9, all right, so 63 times 2, 126, plus 126. Here we have a 0, so we don't need to worry about that. This gives me 706. The other diagonals. All right, so this first one's going to be 0. 6 times 2 times 29, so that's just 12 times 29, 348. I could have gotten there, but again, trying to speed things along. 348, and then we've got 5 times 13 times 7. All right, so that's going to be a plus. Wait a minute. 455. I better check this though. 5 times 13 times 7. 455. Cool beans. And we need to add 348 to that. So that gives me 803. When I do the subtraction between these, so 706 minus 803 is negative 97. Okay, so we're going to hold on to that one. Now for the next one, we're going to do 1, 3, 0, negative 29, negative 13, and 9. Take care of these diagonals. Now this one's a nice one because we see that we've got a couple of diagonals with 0, so we can ignore those. We've got 1 times negative 15 times 5, so it's negative 65. Then we have 0 there and a 0 there, so all right, we're good there. And let's check these. So the first diagonal there is a 0. Then we have negative 18, 5 times 3 times 29. All right. Am I betting man? Okay, so we know it's going to be a negative. Yeah, negative 435. I better check this. No need to make careless mistakes. Cool. And this combines going to be a negative 453. So we have negative 65. That becomes a plus 453. There's just going to be 388. Okay. Now we'll move on to this last one. So 1, 3, 0, 7, negative 4, 6. And let's check these guys. All right. So 1 times negative 4 times 9 is negative 36. We've got a 0 in this diagonal, so he's gone. And then we have 29 times 3 times 6. So if we do the math, that's going to be 530, I don't know, 528, 522. Yeah. But again, let's double check. No need for carelessness. All right. It is a negative, and combined is a negative 558. And let's check these diagonals. So we start off with a 0. 6 times negative 13 times 1 is negative 78. 9 times 3 times 7. We're actually going to do 9 times 7 first because that's 63. Times 3 is 189. So plus 189. This gives me a positive 111. So that when I combine these, negative 558 minus 111 equals negative 660. No, that's not right. What's wrong here? Well, clearly I've done something wrong because this is not making... Something's not right. So that's a 0, negative 78. 9 times 3 times 7. You know what? I'm going to keep going. Because I think I've done the math right. I have not done the math right. See? So I knew something was wrong. It's because of this. I didn't copy the things that were... No, if I just done the copy paste stuff like I did before, I'd be fine. This is supposed to be a minus right here. And I missed it. Which means that this guy right here is supposed to be a minus, which then changes that, and it changes all of this. Ugh. Don't you hate making mistakes? So what would have happened at the end is it would have come up with an answer that didn't make sense with everything else. Gotta watch out for those signs. Man, they'll get you every time. All right, so when I combine this, I get a negative. So that's 7 negative 267. And I've got negative 558 plus 267. You know what? I'm just not in the mood to make more mistakes. Whoops. And what did I do? Well, I just pressed the wrong button. So we have negative 291. So let's take all these and let's see. Our main D value was 97. So X is going to be negative 97 over 97. So that's negative 1. My Y value is 388 divided by 97, which should be 4. Let's just double check that. 388 divided by 97. Okay. And then Z is negative 291 over 97, and that should give me negative 3. Just to double check. All right, so it means that my solution for the system is the ordered triplet. Negative 1 for negative 3. Now, it is well worth your time to take your answer right here and plug those values back into the original equation to make sure that every equation is true. It doesn't take long to do that, and it'll end up saving yourself a huge headache later on down the road. So, check all of your work. All right, up next we have some special properties to look at when it comes to determinants. So let's see how that works.